My name is Nick Rizzo. I am a product specialist here at Opentrons, and I'm going to be joined by my colleague Boren Lin, a senior scientist, molecular biologist by training, specializing in proteomics techniques. Today, we're going to show you the Opentrons Flex and our new Opentrons Flex on-deck absorbance plate reader. This is going to be highlighted by a demo protocol for fully automated BCA protein quantification and normalization. I'm just going to pause here for a minute to make sure everyone who signed up has a chance to join us. And I'll also use this time to plug our demo room where this webinar is taking place. This is in our headquarters in Long Island City, New York. If you or anyone on your team are based out of or are visiting New York City or the kind of nearby areas, please feel free to reach out to your kind of rep, get in contact with anyone at Opentrons and schedule a time to come in and visit us. This is also kind of where we host some, kind of impromptu webinars and demos as well, to check out the office and lab and kind of get to see the Opentrons Flex and all of us great people at Opentrons in person. Okay. Gonna give it one more second here for people to join in. All right, looks like we're pretty ready to go here. Just a quick reminder that this webinar is being recorded and it will be made available on the Opentrons website. We will be sending a copy of the recording via email after the webinar. And just to help with the overall webinar experience, all attendees will be on mute. To ask any question, please use the Q&A box on the bottom of your screen, and we'll answer any of the questions at the end. Okay, let's get started. The first thing is I just want to say a couple of quick things about Opentrons and our ethos and why we exist. It's our mission to support scientists doing groundbreaking, valuable research with powerful, accessible lab automation tools that free you to do more than just pipette. We've helped thousands of labs all across the world automate their workflows, and the Opentrons Flex is our newest generation robot, and we're really excited to show you how it can help you and your lab increase your throughput and free up your valuable time. So I'm going to go and walk through the Flex first here. And kind of just highlight a few of its features before we kind of get to the meat of the webinar about the Absorbance plate reader. So kind of the first thing that I am going to kind of highlight is going to be the on-device touchscreen, which is right here next to me, located on the outside of the robot. This is going to allow you to kind of really easily store, pull up, and run protocols, as well as having the ability to now design protocols through one of our new kind of software tools called Quick Transfer. It also guides you through some of the setup process, whether that's at unboxing or while you are bringing up kind of new modules that you can constantly add to the Flex deck in terms of automated calibrations. These automated calibrations also apply to the pipettes, which we will walk through as well. Also, very importantly for end users, the touchscreen provides a lot of prompts and a lot of guidance, so that it really makes steps as you go through your protocol kind of extremely straightforward, and really kind of lowers the barrier to entry for people newer to automation in your lab to carry out protocols in an automated manner. Now, kind of behind the touchscreen here, something that will be a lot more obvious as we run the protocols is going to be the gantry of the system. The gantry has the ability to hold 1 or 2 pipettes and also a gripper, regardless of how many pipettes are mounted. You can use single 8-channel or 96-channel pipettes on the Flex robot. The single and 8-channel come in 2 sizes, P50, which covers 1 to 50 microliters, and P1000, which covers 5 to 1,000 microliters. The 96-channel currently only comes in 1 size, which covers 5 to 1,000 microliters. The 8 and 96-channel pipettes can also perform what we call partial tip pickups. This allows these pipettes to pick up 1 tip, 1 or more rows or column of tips, as well as kind of several configurations, ranging from 2 to 7 tips within that. This really frees you up to use one of these pipettes in kind of a higher throughput fashion, while also having the flexibility to pipette from things that require a single or a specific configuration of tips. Another thing to note on the gantry is that you can use any combination of 2 single or 8-channel pipettes on the gantry at once. The 96 channel, however, does take up both of the pipette mounts due to its size and footprint, so you can't use a second pipette at that time. But because of the large range of 5 to 1,000 microliters and the ability to do partial tip pickups, the 96 channel does still kind of have a lot of flexibility that you can create a protocol around when you just have that singular pipette mounted. Continuing on to the gripper that I'd mentioned that also mounts to the gantry. This is an SBS compatible gripper, which can move around tip racks or plates to different slots or into the trash bin, or also occasionally a waste chute that attaches to the front of the robot as well. These functions are very helpful when you're running high throughput workflows, as you can discard used tips and restock the deck with new ones. It really does extend the walkaway time that you can achieve on the benchtop robot. In the workflow that we're going to demo today, the gripper is also key, as it moves the plate onto and off of the plate reader, and also removes the plate reader lid from the kind of reading location to its docking location. And to be able to kind of perform these functions in a totally automated and walkaway fashion, the gripper is a necessity. The gripper also, helps in a variety of other applications, such as full walkaway PCR with several of our other modules. But really, it does kind of contribute to the Flex being, as many applications within the box as possible. Moving away from the gantry and now onto the deck. The deck features 12 standard slots where tips, labware, and modules can be placed. We also do have 4 expansion deck slots available, and these sit to the right of the main deck, so they'll be over in this location. This is a specific expansion deck slot currently loaded for the plate reader, but it's a very similar idea for the following kind of 3 positions above this on the robot. The gripper can access all 12 of the standard slots and also access the 4 expansion slots, allowing you to kind of store labwares or tip racks over there and bring them to the deck throughout the protocol. In the demo today, you can see that the plate reader sits across 2 deck slots, with the top of the plate reader being moved between those into that kind of specific kind of version of an expansion slot for that. Okay, now quickly to discuss the modules here. I'm going to start with the plate reader, as that is going to be the star of our performance today. So this is our brand new Opentrons Flex Absorbance plate reader. It's a fully automated module capable of measuring absorbance in the 400 to 1000 nanometer range. As standard, it's going to come equipped with 4 wavelengths filters that are going to support a range of applications. Those wavelengths are going to be 450, 562, 600, and 650 nanometers. These wavelengths should take care of kind of your day-to-day 96 well format absorbance measurement needs, such as for cell viability, protein quantification, bacterial growth monitoring, or enzymatic activity assays, ELISA, Bradford BCA, and so on. It's very quick to install, as are all of our modules, with just kind of a couple of screws. It's going to come kind of fully equipped into its own caddy, so the installation process is going to be incredibly seamless as you add this onto your Flex deck. It is also going to be able to be controlled directly through our Python API, and will also appear in our Opentrons app. So if you are familiar with the Python API to write your protocols, you have this ability kind of immediately unlocked for you once the software upgrade that is going to debut on December 4th is released. Or you also have the ability to download kind of existing protocols from our protocol library These have been put together by our incredibly intelligent scientists here, one of them by Boren, which will be highlighted in this webinar. If you are kind of a primarily protocol designer user, kind of our UI web-based tool, this will be supported in early 2025 to have the ability to interface with the plate reader through that tool set. One important note that I do need to make here is that the Absorbance plate reader may currently not be offered, used, or put onto the market in any European patent convention states due to a third-party patent application. So this is kind of not available for sale in those regions. Now, just to quickly highlight the rest of our awesome modules before we jump into the actual webinar here. We will also have the ability to put onto the deck, both in kind of combination with the plate reader or, kind of without, and in really any combination of these modules, a magnetic block, which is going to be industry standard and be able to house 96 well plates on top of it for things like magnetic bead cleanups. We also have a heater shaker module that goes from 200 to 3000 RPM and from ambient temperature to 95 degrees C. A temperature module, which can go from 4 degrees C up to 95 degrees C. A thermocycler module, which can automatically open and close via the software, which is a really unique offering, allowing for kind of fully automated PCR and other workflows that allow you as the end user to totally walk away from the instrument. And then finally, up on the top of the instrument here, you can see one of our newest modules, the HEPA UV. It sits kind of very neatly on top of the robot and sterilizes the deck using UVC and also filters contaminants with the HEPA and the fan from the workstage area. Okay, now we're going to jump into the assay, and I will bring Boren on to discuss this, and I will fade into the background.
Hello, everybody. I'm Boren. Thank you, Nick, for the introduction of our system here. Today, we're presenting a protocol that can do BCA assays for our proteins concentration measurement. And they will read the plates on deck with this pre-reader we just introduced. And then we do all the calculation in the background to determine what is the values of the samples and the buffer used to normalize our samples. And the last part of the protocol, we're doing actual pipetting to dilute our samples to our target concentration. Let's just jump into the protocols. Nick, can you show? This is the touch screen we're seeing right here, but I think our camera cannot zoom in close enough. So we'll switch this screen to a screen that makes us clearly to see that. Is it ready to go?
Yep.
So first of all, we have our protocol loaded in this robot. Right here, we can select this protocol. It shows up. And I want to introduce a very important features of our app. Here, we can start the setup. That give you all the options we need to set up the assays. For the first options we hear is called reference wavelengths that allows us to determine if we want to use a reference readings in our assays. And the second one, we can see there's a standard reading preview. So in the middle of the process, we'll be able to check if our readings make sense. If it doesn't look like it's correct, we can stop the protocol and rerun it, or we can prepare our new standards. And we can select how many samples we can run. So this protocol is designed to run up to 40 samples because all the samples we do it in duplicate. And then we can select, we want to keep our samples in what type of labware. We can choose to do 2 ml deep well plates or regular 200 microliter PCR plates, And then we can select how do we want to store our standards. We can put it in 1.5 ml tubes when we can also put in our 200 microliter PCR plates. And then, so here, I just mentioned it's doing in duplicate. Actually, we can select how do we want to dilute our samples. So sometimes if our concentration, we know our concentration is too high, we want to dilute it to get the correct readings. We can select, we can do a, like, we can do a 0.2x dilutions or 0.2x dilution, meaning we dilute it twofold, we can dilute it in fivefold. And if we don't dilute it at all, it's a straight duplicate. We read it twice, basically. So we can also select incubation time. For now, I select hold, but you can select 10 minutes, you can select 30 minutes, depends on your need. If we select hold, meaning it will go, the incubation will start and hold until you stop it. And after that, we have, for this particular protocol, it allows us to select, to put in 6 standards, meaning you put down the concentrations of your standards. You can, from highest to lowest. And so your assays, the assay range will based on your standards. Your highest standard you put in or the lowest standard you put in. And also you want to set how many, what is the values you want on your sample after you normalize your samples. For example, in this case, I select 100 microliter. And also how much proteins you want to put in your final plates. In this case, I put 30 microgram. So in this case, once you prepare your normalized plates, all the samples are normalized to 100 microliter with 30 micrograms in each samples. And the last selections, you select where do you want to put your PS1000 single pipette. As Nick just mentioned, we can put 2 pipettes on the robots. In this case, we put PS1000 A channel and PS1000 1 channel in this case. So now everything is confirmed. So once you have loaded your protocols on the robots, you can operate everything on the touchscreen. And of course, you can also go back to your lab, laptop and work on your app. And now let's switch to focus on this robot because we're gonna run it right now. So we are all familiar with these BCA assays. The first of all, we're pipetting our samples into our working plates, which usually a flat bottom 96-well plates. And we don't have to use special plates for display reader. We just use our day-to-day labware in these settings. And we can see the pipe. So in this particular protocol, the first step is to pipette standards from our standard plates to these working plates. And you can see it's pipetted twice because we're doing it in duplicate. So as I just mentioned, we're using the tips specific for this robot. But for the other labware, like the assay plates and the plates we use to store the samples and the standards, we can use the labware we are commonly used in our lab. We don't have to switch to a specific format. So right now it's picking up the samples. This protocol is designed to run up to 96, but for this demo purposes, we'll just do A samples. And you can see they're using the A channel pipette to pick up the A sample at a time. It's very efficient. And it's doing the second pipetting for the same set of the samples, which is the duplicate. Now it's finished the sample extender pipetting. It's gonna start transferring our working reagent. So in this particular protocols, we're using 50 microliter tips to pipette our samples and extenders. And we are using 200 micro tips to pipette our working reagents. So it's now pipetting the working reagents into our assay plates. The assay plates come with a lid. So there's a modules that we haven't talked about is this module right here. It's a heater shaker. It allows you to shake the plates, which is very important step in the BCA assay, and also you heat it up, maintain the temperature at 37 degrees, which is also required when we're doing our incubation. So these modules provide these two functions. Now we are finishing all the sample pipetting. And let's see how the gripper is going to be doing. It's picking up the plates, and it's going to move to a shaker. And then they're going to shake the plate to mix the reagents, the reagents and the samples and standards in the plates. For the demo purposes, we only shake for a few seconds, but we can adjust to do like a 30-second, more like a standard process in this in this assays. Now it's done shaking. The gripper is moving the plate back to its original slot. And then as I mentioned, this the heater shaker is already also have a heating function, so it's gonna heat, and then it's maintain the temperature of 37 degrees. So now we're putting the lid on the plates. Yeah, because we usually we maintain this incubation at 37 degrees for 30 minutes. That's why we need a lid to prevent evaporation during the process. As I mentioned at the very beginning, when we set up the protocol, when we set up the incubation time, I didn't set up 30 minutes. Instead, I set it up to hold because now we can continue. We don't have to wait for 30 minutes. We can already continue to the next process. Let's imagine it's already 30 minutes. We passed 30 minutes. And it's now moving the plate back to its original position. Basically, we finish all the BCA assay process. Now the plate is ready to be read. So in the protocol, once it's launched, we will give you the options to, if you already have the plate reader and you don't really have to do this, you don't really have to do the following normalization step. You can use your own plate reader, and we will offer the chance you can manually grab your plates and to your plate reader. But in this particular case, we want to read the plates and then go ahead to do normalization. Now the gripper is moving the upper part of the plate reader and then they will allow the gripper to grab this the assay plate, which already have our reactions happening, and then move on the plate reader. And that's it. The place has been read. And now all the readings are collected and processed in the background. Remember, we have already set our standards. We have those numbers. Now it's calculating in the background to determine the values that when we move on to do our normalization process. And as I also mentioned previously, when we are setting up the protocol, there's a way we can check if our data looks good. So in a few minutes, we will see the data showing on the screen. This is kind of important when you run this assay the first time. You want to check all your standards, everything works. But once you've done this, when you set up the protocol, you can actually skip that steps. So you don't have to pause the protocol to read those numbers because you already know it's reading. Now it's showing the first column, which we have the standards, and and also you can check the first column is the duplicate of your standards. Let's say all the numbers looks good. We want to continue, and then you will move on. We can skip that steps, so you can continue the whole process directly to do the normalization. Now they're doing the normalization. They got the numbers of what the value of the buffers. So it is transferring the buffers into the new plates. And after they transfer the buffers, they will then transfer the samples to the plates and dilute the samples to our target concentrations. Now, while the robot is still running, we want to quickly show you some data. Nick, could you able to show those data? Yep. So in the first slides, we can see there's this is the first steps. Basically, we prepare the samples, we mix with our reagents, and then we're gonna move these to a Prairie reader. And second slide. So here is, we don't see this because this is calculated in the background. So the first step is to use those standards and generate a standard curve. And then we do a point-to-point curve fitting to kind of to calculate all the concentrations. The protocol we develop can automatically rule out those numbers who is not within the assay range. The assay range is determined by the standards you put in the first place. And then it will collect all the data that is suitable to be normalized. And it's actually also ruled out the concentration that is too low, because if the concentration is too low, it won't be able to further dilute to our target concentration. So which is step 2. And go ahead, so the step 3 is what it's doing right now. It's actually diluting our samples and then transfer to a new plate with all the concentration normalized to our target concentrations. And then we run the BCA again, and we can get these numbers that is, and in this case, our target concentration is 500 microgram per microliter, and it's shown on our final BCA results that the samples are successfully normalized. So these protocols can be easily added to our. It actually depends on what you're gonna do next. If you want to do a sample preparations for mass spec proteomic analysis, after you can add this protocol directly to that sample preparation protocol, and the final plates, the normalized samples are ready for our trypsin digestions. And if you want to do a Western, we can add a simple step right after this protocol that will allow you to edit the SDS loading buffers into the samples. And on the deck, you can heat up your samples, and then it's ready for your SDS page. It's for example, if you are in the lab, which is running like day-to-day your therapeutic antibody screening, and then you can run this protocol, and you can use the final plates. It's already normalized. That's your you can use your samples such as the your collection of media you have from your, for example, CHO cells culture expressing different antibodies, and you can normalize it, and then it's the final plates is gonna be ready for your screening assays. So this is final. This is finishing the last 4 samples of normalization. So considering this is kind of, we have this robots in our lab doing like day-to-day experiments like ELISA, cell biopsy assays, protein assays. This is taking care of your routines, and as we just mentioned, there's we just need a play reader, a shakers, and then we supply you the tips that is necessary for this work. And all the labwares you already use in your lab, you can put it on this robots, and you can play with the script if you like all the changes, or we are very happy to help you to develop the protocol to fit your need.
Perfect. While this is finishing, we can probably start to hop into some Q&A while this is finishing up behind us. So just a quick reminder, any questions that you have, both regarding kind of what was shown in this webinar or any other kind of Opentrons related questions, we're here to help. We can start off with a few that have been rolling in. Boren, I'll let you handle this first one. What is the runtime when processing a full plate with 96 samples?
So I'm looking at the time right now we just run this protocol just run like around 15 minutes to run 8 samples. To run a full plate of 96 samples is probably take you 40 to 60 minutes. But you may feel like this is not very attractive. If you do this by hand, it's probably going to go much faster. But the benefit of using this robot is you can click the bottom and walk away. The robot is doing the bench work for you. You can go back to your desk, working on your grant writing, working on your papers, working on other more important experiments. So that and imagine we are running in a lab, so we are doing routine work for all kind of assays that need that require absorbance measurement as our readouts. And the Flex with this spray reader is probably our most reliable and automated solution.
Absolutely. Let's go into another one. We have a question coming in that says 1.5 mil Eppendorf or 2 mil Eppendorf is compatible for putting samples into. So I believe that this is just asking if it's possible to have those kind of those labwares on deck.
Yes, that's possible. We have a special rack for those tubes, 1.5 and 2 ml Eppendorf tubes, and in our when we're doing our protocol setup, we gotta choose what kind of labware we want to use to keep our samples or standards. Yes, the answer is yes. It's available. Yeah.
Okay, perfect. Thank you, Boren. Moving on to the next here. Does the software have general functions kind of typical to other microplate readers in what they offer. A little bit of more explanation here. For example, how were the sample concentrations estimated, and can we choose the different kind of curve fitting methods after this has been read?
Well, unfortunately, right now our app is not yet have those functions. Well, if we're so in our lab, the play reader we're using always come with the software with all those functions. We don't have those yet. But we can, for this particular example, we are using 6 standards. If you want to change to fewer or more standards, we have to modify the protocols to solve this problem. And also, this particular protocols, we use point-to-point fit. If, let's say, we want to do a full parameter logistic fittings, we again have to reprogram our protocols. So for now, the play rate is run depends on how the protocol we're designing. It's actually give us flexibility how we want to include the features in there. But we're working on adding more features in our app. For right now, the protocol is developed very specific to the applications.
Thank you. The next question here is going to be, how much dead volume is there? Further explanation is, how much excess do you need in the wells? I believe that this is during the plate reading step.
Yeah, that is a very good question. It depends on the labware we are using. If, for example, if you store your samples in like a 2 ml deep well plates, the depth value is higher than if you're using a 200 microliter PCR plates. So yeah, I would say maybe 5% depth values we're talking about. But yeah, it depends on the labwares.
Absolutely. Next question here is going to be, what does the export file for the BCA data look like?
It's a so this particular protocol, we don't really need this as CSV files created because it's directly grab the data from the play reader and feed into the normalization steps. But if you want to check those data, we can put it out. It's safe in CSV file, and then we can put it out from our run log. I'm not sure if I answered this question correctly, but
yeah, I can also just show quickly sharing my screen.
Yeah.
So this is just a very quick example. This is from some dev work that I was doing in the background here. So all of these values are read out as zeros on the screen currently. But this is kind of the format that would be typical for the output here. So it's just going to come off in kind of a 96 well plate format here. And so all of your concentrations for whatever wavelength you had initialized the reader to be performing this read at are going to kind of populate into some of these cells. Okay, great. A little bit of extra info there. Okay, next, an anonymous is curious to know if this plate reader has been successfully used to directly monitor E. coli cultures prior to IPTG induction. If so, what plate geometries and weld volumes have been used? And if it can't, what sample volumes would be required? Boren, I don't know if you have any input on this.
We haven't done this yet, but this is in our like to-do list for sure. For now, we develop this protocol to test BCA for demonstration purposes, and we're gonna move on quickly to test all the ELISA, self-validated assay, and also the microbiology applications. Yes, we're gonna have this in the future, but we don't have it yet, unfortunately.
Yeah, absolutely. And you are in here as anonymous, but for whoever asked the question, definitely feel free to also reach out to us either through support or through your rep if you have one available already. And kind of just posit kind of this question to them and kind of stay up to date on it. This is definitely something that we would work kind of closely with you as this process kind of gets kind of kicked off. It's definitely something our science team definitely works collaboratively on some of these kind of like newer protocols that we would like to develop, especially ones that are kind of viable for larger audiences like this would be. Okay. Are there plans to expand into lower UV wavelengths, 260, 280? And so no, there is kind of not currently any ability to expand below the 400 nanometer into the kind of UV spectrum for this plate reader, unfortunately. Can the plate reader be used to acquire a full spectrum of a solution? If so, what would the approximate time per sample be? Also for this one, no, so it will read at discrete wavelengths. The ones described previously, right, are the 450, 562, 600, and 650 nanometers. And so it will only be able to read at those discrete wavelengths. You can kind of perform initializations and read at each of those. So if you need to take readings on a plate that are more than just one of those wavelengths, you do have that kind of capability, but it does not have the ability to move kind of continuously throughout that spectrum. Okay, next question here is going to be, actually, yeah, what are the wavelengths the plate reader can read, and can it scan through it again? So already answered that one. Gopal would like to check system suitability, and based on system suitability to take decision whether they would like to take next step or not. Is it possible that we can put checkpoint in software? So essentially, I think it's like if it was possible to perform the read, look at that output file, and then choose kind of what either to move on to the next steps, or probably to kind of backtrack.
Yeah, yes, this is possible. We just have to build, we just have to reprogram the protocols we have now to actually create those checkpoints.
Mhm.
Yes, it's doable in the so we actually we kind of just show a example of how we can check the data. So right now the protocol can allow you to check if the standard reading is good. And also we include a positive control readings. If you see the positive control readings is the numbers you were expecting, then yes, let's move on. But if there's something wrong, we can stop the protocols and prepare the samples or do something else.
Yeah, and also just as a quick note on this, so in this kind of protocol that Boran just showed, right, it does have kind of like the really unique and like awesome ability to be performed in this fully automated fashion, right, where the plate is prepped, right, that you can perform BCA assay on the samples, and then perform the readouts, and then actually use that data, right, kind of intrinsically within the protocol, right, to inform the next steps. Here it was a normalization before kind of continuing to another BCA. However, like you can also break those steps out. So if it makes more sense for your protocol, right, to end on the plate reader step, and then just remove the plate from it, and then kind of return the plate reader back to a neutral state, and then say, hey, like I'm going to take this data, I'm going to do some kind of manual interventions here, whether that's kind of fitting it to functions that it's not capable to do within the Python kind of like knowledge base, or just perform other checkpoints. That's also totally a viable way to utilize the reader, right? So while we do have this really compelling offering of performing it in a totally automated fashion, if that doesn't work and it doesn't make the most sense for your protocols, you can always break those apart. Have we tested the capacity of the absorbance module for drug quantification?
Oh, that's a good question. No, not yet, but we are very interested in doing that. We are welcome to collaborations. So if you have the applications that you want to test, please reach out to us. We can work together. Yeah.
Yep, absolutely. And again, so if you have your kind of local Opentrons rep, they're always a fantastic resource. Or you can reach out to us through our website. The kind of chat is actually monitored by a real person. So if you have specific questions and specific needs, they will actually also help direct those inquiries kind of directly to us. But definitely is something we're highly interested in. 96 well plates are typically sealed during incubation to avoid evaporation and sample loss. Can the Flex seal unseal plates, or is this a task for the operator?
So right now we're using the lid right here to cover the plates during the incubations. We don't have the capability to automatically seal the plates right now. The way we're doing is pause the protocols and prompt to the user to seal the plates. So this gonna add a manual steps in the process. So yeah, for now, this is our solution.
Yeah, we do have actually some disposable seals for the thermocycler that we've just debuted. So if they were ever to want to do an incubation step on the thermocycler, you wouldn't be able to shake, obviously, but if that was what they desired to do, we do have some consumables that are actually just about to debut, pretty excitingly as well, that assist in some of those high throughput fashions. But yeah, the automated sealing, de-sealing is not something that's equipped on the Flex currently. Yeah. Okay, that looks like all of the questions that have popped up so far. One more. If they are not a Flex user yet, very important yet in there, can we collaborate to develop a specific protocol to meet our lab's needs prior to purchase? I think that this would kind of depend upon the complexity of the protocol as well as kind of what its kind of general validity is. And kind of another point on that is we didn't highlight it here, but we do have a protocol library where we are continually adding kind of industry relevant protocols too. And so there is a possibility that we will kind of be covering protocols that are kind of pretty specifically tailored towards your assay anyways. So I would also recommend reaching out to a sales rep really specifically for this kind of ask here. And in that case, we can definitely provide further visibility into kind of what the general science roadmap is for what is planned and what is going to be covered on this. Typically, we will also provide the ability after Flex purchase to have one of our field application scientists assist in protocol creation and validation with you as well. Or anything?
Yeah. If reading the plates is your kind of the last step of your assays, then we encourage you to search our protocol library to see if there's any protocols they already created to kind of to prepare your plates until the last steps.
Definitely.
And then we can quickly add, we can easily add the final play reading step to you. So that's, I think it's less complex in the process.
Yeah, absolutely. Okay. I think that will do it for questions. Thank you everybody for attending. We're very excited to debut the Opentrons Flex Absorbance plate reader. Thank you, Boren, for highlighting how
Thank
we
you, Nick.
can perform these in a fully automated fashion. I know that anyone tuning in with some lab background experience here is probably very excited to see an instrument do all of the normalization steps for them.
I'm very excited.
All right. Thank you, everyone.
you.
Have a good day.